really glad that you're able to join us this evening for Dr. Anders Sandberg's talk. Anders has a background in computer science and computational neuroscience, I believe, with an MSc and PhD from Stockholm University. And he works at the Oxford Future of Humanity Institute, and tonight we will be presenting on the future of cognitive enhancers. So without further ado, please join me in welcoming Dr. Anders Sandberg.
Thank you very much. It's always fun to have an excuse to return to dear old Oxford, where I've been living for 7 years. Yes, and this talk, some of you have probably heard previous talks about cognitive enhancers from me. So I'm having some really good news to you. I'm actually updated my talk slightly. But the main focus is really, what can we do to reduce things like this? These poor soldiers are standing around with the tank they just downed into a swamp. And they're probably not right now trying to figure out what to tell their boss. And if you're a normal human, your reaction at this point is of course going to be higher blood pressure, your heart rate goes up, and your blood would be more effective in clotting. Why? Well, this is the reaction, the fight or flight reaction, that works really well if you're getting attacked by a predator or need to escape from one. It's unfortunately not the right kind of reaction you want when you want to be creative in coming up with a really good excuse for why you drove a tank down into a swamp. We're not really well adapted to the modern world and its problems. Partially that is probably, I don't know the story about this particular image, but this might also be why they drove a tank down into a swamp, because driving tanks is very, very different from what our ancestors did on the African savannah. The fact that you can construct tanks and drive them around even a little bit is quite awesome. No other animals do that. But the problem is we created this very complicated world where we're doing a lot of tasks which are very advanced, and we're not well adapted to dealing with them. Sometimes this might be because of simple natural limitations of our attention or our memory. Sometimes it might be that we create systems that are simply too smart and complicated. We have created a lot of little subsystems which are smart in themselves, and then we plug them together into a gigantic network where everything is feeding into everything else and nobody really understands what the whole picture is doing. One reason I'm smartly dressed is that I've been spending the week in the city of London among a lot of very smart people who set up extremely complicated systems that involve enormous amount of money and risk moving around in fantastic ways that nobody really understands. This is somewhat worrying, of course, given that this is kind of fundamental for a lot of our economy. So, what can we do about it? Well, it seems like the standard thing to say is we should become smarter. Now, smarter is one of those rather vague words. Intelligence is the fancy version of smarter, but it's also somewhat problematic. And indeed, quite a lot of people disagree about whether there even is anything like intelligence. In a sense, it's a bit like the word wealth. I think we can agree that some people are wealthier than others, but we find distinctions are kind of tricky. If we measure how much money there is in the bank accounts of people, some people are going to have more. But it wouldn't surprise me at all to find that Bill Gates doesn't have an enormous amount of money in his checking account. His wealth is kind of distributed in completely different things. So putting together all the stuff people own, and in a way that you can compare it, is very tricky. Similarly, intelligence. If we use that as a kind of shorthand for general cognitive ability, I think in general we tend to recognize it when it's occurring. But there might be interesting fine distinctions, and indeed there is an ongoing debate in the psychology community whether it actually is some kind of core factor and then there is specialization, or whether there are some very, very separate things. I think the consensus these days is mostly that, yeah, there is a few core factors that are probably used in a lot of very different problem solving. The kind of intelligence that we normally talk about, especially being academics, is of course the kind of intelligence that makes it really easy to be an academic. Ability to solve puzzles, to figure out what the tests are on the exam. Ability to solve equations or figure out complicated visual patterns so you can find your way from one quad to another. There are other applications, of course. It might mean negotiating with other people, convincing them that you're a good guy and that they should vote for you. That also requires mental abilities, but somewhat similar, somewhat different ones. And you have, of course, a lot of people say yes, and then there is musical intelligence and emotional intelligence and so on. Typically, these ones tend to come together. It's kind of unfair that way. That if you're really smart at the visual spatial stuff, on average, you tend to be better at a lot of other things. There is no guarantee about that. And notice that this doesn't mean that you have any shred of common sense, which is kind of an interesting thing. Many highly intelligent people have amazingly bad common sense. And a similar motivation, I think most of us realize that we're not half as highly motivated as we actually think we ought to be. But well, the lawn is so nice and it's sunny outside, so why think too hard about it? So looking at the benefits of cognitive ability, it turns out that if we just use IQ as an admittedly weak measurement, you can find a surprising number of things that it correlates well with. And not only correlates, it can actually predict. So I mentioned that, of course, it's good for doing well in school. And also it turns out that job performance on really complex jobs tend to do well. Now this is slightly tricky because generally getting good grades mean that a lot of doors open for you and you can get into a job. But many of the simpler jobs, your intelligence doesn't matter very much for. However, if it's a really abstract one, then it's a bit similar to academic problem solving, and then it might be helpful. However, in many cases you need other things like emotional intelligence. If you want to kind of get people to pay their debts, you need high emotional intelligence. It's a hilarious little paper about it. It also turns out, of course, that this is good for your income and so on. But childhood intelligence also predicts health in later life. And maybe you could argue that, yeah, some people are more evolutionary fit. They're already made of good stuff and are going to do well. But a lot of it simply seems to be that they don't do stupid things. Or when they do stupid things, at least they wear a helmet. Indeed, this has a longevity effect. So in high childhood intelligence, a pretty good predictor that you're going to live on average fairly long. And the risks of accidents go down. And even the risk of being a murder victim. And again, it's not because the geniuses among us are very smart at talking their way out of a life-threatening situation. It's mainly because the people who are doing the worst seem to be pretty good at getting into trouble. Incidentally, this study was done in Sweden. It was using the intelligence test given to all Swedes for the draft. Now, this is interesting because you have a longitudinal data set with millions of Swedes. I'm one of those little data points. And this being Sweden, of course, everything is stored in a database somewhere where our almighty and the friendly government can give certain researchers access to, despite the creepy privacy implications, and they can do amazingly good studies this way. So I forgive this study at least. I'm very happy to be one of those little data points. Another really interesting aspect of being smart is that on average you tend to be more economically rational. So this was also demonstrated in a natural experiment that happened in the American military. So they had, if I remember right, it was something like they needed to retire a bunch of people and they had two different options. One was that you get a whole bunch of money right now. Another one was some kind of slightly slower scheme, which would in the long run mean that you had more money. But you needed to wait, of course, a little bit for it. And there was a pretty clear correlation here between the grades on the military intelligence test and whether people were choosing the deferred reward, which of course made them better off for retirement. It also turns out that actually smarter people are better at figuring out economic games and cooperation and things like that. So it would be probably a good thing from a kind of human perspective, more of us became smarter. It doesn't seem that intelligence makes us happy. If you're smart, you're good at becoming unhappy about weird things. I mean, just think about academics around you who are upset about the properties of quantum mechanics or the philosophy of Wittgenstein or other things. On the other hand, you also will probably find the colleagues around you that are really happy over these topics. I mean, the fact that spin behaves like it does is pretty awesome, actually. On the upper end, this doesn't really have any particular effect. However, people who are on the dumber end, they tend to be pretty unhappy. Because life is not working out as it should for them, their plans are failing, and a lot of people are fooling them all the time. So ideally, it seems like we should actually be aiming for our own sake and for others to try to become smarter. It's also kind of economically good. It might even have some network effects which are pretty big. 1 IQ point might actually be worth a few % increase in gross national product. In fact, it has been argued by some economists that it might be rational on a national level to make everybody smarter, but individually we wouldn't benefit that much individually of getting slightly smarter. This is not entirely true, however, because we would be living in a richer environment, which would presumably, if we allocate those riches in a nice way, actually be nicer to live in. Okay, but what can we do about it? Well, there are quite a surprising number of ways we can make brains function better. One of the absolutely simplest one is, of course, make sure that we get enough hours of sleep each night and keep the room really dark and quiet, which is very hard for us nerds who have enough computers and little blinking lights to make it look like a discotheque. Get rid of the lead from the drinking water, which might destroy our brains, and get enough exercise. These are, well, in many ways, an obvious thing to do, but they're also quite important. And throughout most of history, of course, they have not been the thing most people have been able to get. The fact that our nutrition has become so much better over the past century is probably not a small fraction of the so-called Flynn effect, the observation that IQ scores have been increasing at a fairly rapid pace throughout most of the 20th century. Another way of becoming smarter is, of course, to train ourselves. So one classic example is, of course, to go to school. 2.7 IQ points per year, according to one study. It levels off eventually, unfortunately. Very sad. We need to figure out how to stop that and make it continue indefinitely. But again, the trick here is, of course, that you're getting told a lot of stuff, but you're also learning how to express yourself, how to solve problems, essentially you're learning mental tools. And of course you get to interact with a lot of other people, which is of course one of the biggest challenges and actually requires quite a lot of our brain capacity. That's probably the toughest thing. Yeah?
The 2.7 points, or did you just mention 2.7 points increase in IQ when schooling?
Yeah, per year, basic schooling.
Is that like the Flynn effect? Is that worldwide? Like, do you see that?
I don't think this study was big enough. This was in New Zealand.
I went to school in the States, and I think it might have a reverse effect.
Yeah. Yep. Yeah, but that's of course the little problem here. You might always question a lot of these studies. I would say that many people would also argue, in school you're probably not learning intelligence in the kind of free-floating liquid form that we care most about. But also you would get it in the crystalline form. You would get particular skills. And if you're good at problem-solving school-type problems, you're going to do great, of course, in a school-type IQ test. So there is a risk that that will not measure real intelligence. So if you got out in an entirely new situation, you might be less able to handle it. And it's a very good question whether different schools actually produce the same results. And I think it's pretty clear. No, that's not true. Different school systems definitely focus you in different areas. Even assuming that they, in some sense, give you the same amount of intelligence, it might be very different styles of intelligence. So there is more to this than just the kind of maximizing some little IQ score. Another form of education is, of course, to train yourself during various mental techniques. So I gave a version of this talk at Münster a few weeks back, and one of the lecturers, he's a memory champion. So he started his talk by memorizing a deck of cards. He was just standing there, giving his talk, and after leafing through the deck, he handed it over to somebody in the first row, and indeed could rattle off all the cards. That was kind of totally trivial for him. He could do that while giving a lecture, because when he's actually in a real memory championship, he would be memorizing 2 or 3 decks of cards that have been mixed together. That's a technique anybody in this room can learn. We could all do that if we actually wanted. And if we were dedicated enough to learn the technique and train it. Similarly, working memory. You've probably been told that, yeah, human working memory is 7 plus minus 2 objects. It turns out, of course, that you can train working memory tests, and indeed, if you keep on doing it, you can give yourself a working memory for at least this kind of test of 30 items or more. That's awesome. However, these systems of memory training have a little downside, that you actually need to train yourself. And that's kind of annoying. I studied some of these systems, and many of them have a beautiful ancient history. We have, during the Renaissance, Ars Memoria, where people were memorizing entire books and building memory theaters, kind of mental virtual realities, where they wanted to put in all the information they knew in a nice pattern. Really useful if you didn't have paper or computers around. But I do have papers and computers around, so I don't really feel compelled to use these methods very much. The only memory technique I'm actually using in everyday life is to remember grocery lists. And I'm kind of feeling that the shades of Giordano Bruno and all the other Renaissance scholars are kind of looking down from the clouds at me. No, youth of today, yeah, no ambition. There are also other interesting ways we can train our brains, of course, by, for example, meditation. Meditation might actually be that you detune your attention system in really weird ways. And essentially, by learning how to focus intensely or learning how to unfocus intensely, you can kind of get your attention system into a mode of extreme flexibility. And at the very least, it seems to be pretty good for the emotional calmness of people, which is not a small part of actually functioning intelligently. An awful lot of people get really nervous as soon as we get a test in front of them and do badly because of that. So the problem here is, of course, that in many cases it's the other part of the brain, not really the real intelligence, but how calm you are, how well you can focus, how well you can sleep, that actually matters. Also, there are, of course, interesting collective methods like the scientific method and market where we can get ourselves smarter. But I'm going to try to talk a bit about the more science fiction-like aspects on the right side here, because, of course, that's more exciting. And, of course, that's also where people start asking for help from the bioethicists. So we like to play up how important they are, because that gives us job security. So it turns out that biomedical enhancement of the brain, it's surprising actually how much we can do. It's also annoying that many of these things are not enormously powerful. But in terms of memory enhancement, we actually have methods that seems to be improving encoding. There are some tricks that might help you retrieve information. Attention is fairly well known that we can modify. And the most typical example is, of course, people taking Ritalin, which tends to focus attention. Impulsiveness is also related to this. How well can your frontal lobe tell the rest of the brain to shut up and don't do that? It's not a good idea. For example, the small amount of alcohol in this glass is kind of reducing my frontal lobe's ability to do that, which is, of course, producing the interesting possibility that I'm going to be more impulsive during the talk, which might make it much more entertaining. Especially given that my brain is kind of not very used to it and I'm a complete lightweight when it comes to it. We're going to get back to this interesting problem that actually the individual variations might be one of the biggest problems for enhancing our brain. We might need to tune quite a lot to how we function individually. Sleep reduction is another obvious one. We have all tried running an all-nighter by drinking ridiculous amount of coffee, Red Bull, and other stuff. And the results, I think most of us would agree, are kind of mixed. It's possible to avoid getting to sleep. That's not really the problem. But actually getting useful work done, that's very different. But there are different ways we can do it. The problem seems to be that sleep is evolutionarily extremely well conserved, and that should give us a pretty important hint that it's important. After all, if you have an organism that is spending a lot of its time being vulnerable to predators and accidents, evolution would probably try to minimize that. But for some reason, sleep seems to be really common among all organisms, not just mammals. So that gives us a hint that, getting completely rid of sleep might actually not be feasible without really remaking our brains and how we function. Which would be quite interesting, but an ambitious goal. Working memory, as I'm going to get into, is also kind of important because those training things seem to work well on just the kind of material you trained yourself to. But when solving a tricky problem, now you need the working memory on the fly. Rather than memorizing a long list of things, you need to keep a lot of balls in the air at the same time and put them together into a nice logical argument. So this might be one of the limiting factors of real intelligence. Another interesting and perhaps mildly creepy one is pro-social behavior. It seems like, of course, our emotional systems are having a biological basis. And we can affect that by hormones like oxytocin, which means that people actually become more willing to trust strangers and cooperate with others. And this might, of course, be seen as very nice and useful, except that, of course, you might both think about an interesting misuse potential, about trying to make everybody else wussy and cooperative, and that some of them also seem to be creating a nice cooperative feeling for us in the we group. But those outside, oh, they can go to hell. So there seems to be some evidence that at least the built-in systems might not give us the right kind of pro-social behaviors that we might want. On the other hand, there is some interesting evidence that this can also, you can reduce racism by giving propanol, a beta blocker. So by reducing the fear reaction, you might actually make people less racist, which is also kind of interesting and mildly creepy, because you can totally imagine some well-meaning people say, and that's why we need to add this to the tap water. Creativity is another interesting case. The classic creativity enhancer is, of course, alcohol. Alcohol turns out to be pretty lousy at improving creativity if you drink it when trying to solve a problem. It's also pretty lousy to drink when you're kind of producing it. But if you drink a bit of alcohol and then go into what's called the incubation phase, where you're not really consciously thinking about the problem, you're doing something else, then the chances that you have a good idea when inspiration finally strikes seems to go up a bit. But this is probably because it just disinhibits the brain. More possibilities are explored, and some of them might, by sheer chance, fit together and become useful. And this might also, of course, be very different in different people. So it might be that some other people, even a small sip of alcohol, go by creativity. So again, there's quite individual things. And in general, I don't know whether you can read this because it's too much text, and it's mostly just to awe you that I have a long list. There is an awesome number of drugs that have at least some scientific evidence, not necessarily the best one, but at least some evidence that it can improve cognition. So I mentioned alcohol. We also have, of course, the classic ones like stimulants like amphetamines, which are really good, except that they might be somewhat addictive and illegal. But besides that, they actually do seem to improve learning and reaction time alertness, but they also tend to move you towards using fixed behavior patterns. This has led to some interesting problems, because if you're on amphetamine, you tend to react as you learned to do in the past. This is not very good if you're running a gunship, for example. So there was a friendly fire incident a few years back in Afghanistan where some American soldiers fired on some Canadian ones. And later on, of course, the US military is on record in court saying, in regards to these pills, oh, no, amphetamine is perfectly safe. We've been using for years. It's kind of nice to know their view on drugs. Actually, they also kind of realized they had a problem, so they have been gradually moving over to another stimulant, modafinil, which happens to be one of my favorite enhancers. It was originally developed to treat narcolepsy. Narcolepsy, as some of you might know, is a condition where you suddenly fall asleep. As Barbara Sahakian, one of the big modafinil experts over in the other place, typically explains that if you fall asleep during this lecture, that's just because you're tired or because I'm boring. If I fall asleep, then it's probably narcolepsy. It's normally a fairly rare disease, but half of Silicon Valley has declared itself suffering from narcolepsy, and the sales of modafinil are going through the roof. So either we have an amazing epidemic of this previously rare disease, or a lot of people are just taking it because they want to stay awake. And it seems to have pretty good effects on alertness. You get sharper. You might also be able to control your thinking a little bit better and so on. So it seems to be quite useful, and I can totally see why you might want to give that to the gunship pilots. In particular, there's a hilarious study where we looked at humor appreciation in sleep-deprived military people. So, when you're sleep-deprived, you don't get jokes as well as when you're fully alert. And this is actually a pretty good sign that your frontal lobes are not doing a good job. In order to get a pun or a joke, you actually need to see a lot of alternatives. You need to be flexible in your worldview. And if there's anything you are not when you're sleep-deprived, is being flexible. You just want to get to bed, or you just want to solve things in the way you always done. So they tried, first you sleep-deprived people, and then you give them various tests. And they also gave some modafinil and some amphetamines, and they found that they had about the same effect on these standard psychological tests of vigilance. They also gave them humor appreciation tests, Is this a funny joke? Is this a funny joke? And it turns out that the people on amphetamine, they couldn't distinguish funny from unfunny jokes. Don't ask me how we originally set up this collection. That must probably have been a pretty funny sub-project on its own. But the people on modafinil, they actually got the jokes. So that's kind of evidence that, yeah, this is probably pretty good for frontal lobe function. But there are quite a lot of other ones. Caffeine is, of course, a classic. And it's amazing from several perspectives. One is because it's such a wussy enhancer. What it's essentially doing is blocking the receptors in your brainstem that find... now the alcohol obviously kicked in. Adenosine. So typically your cells are processing a lot of chemical energy in the form of ATP, adenosine triphosphate, and some of that adenosine gets loose, and that's kind of signal that work has been done here. That gets detected by these receptors. The receptors tell the right part of hypothalamus to start yawning and they make you tired. Now you can mess up this system, of course, by jamming in a bit of caffeine. This actually doesn't fix the problem that your brain has been working quite a lot and so on, but at least you get a weaker signal from the hypothalamus about that you should be going to bed. It's also amazingly non-toxic. I think the lethal dose to an adult human is about a few grams. Now, a few grams of most of the other things here will probably just make you explode. So it's kind of an interesting substance. And the most interesting part is it's, of course, widely used and completely accepted, and people don't really think of it as any weird drugs. Framing your morning cup of coffee as, now I'm going to kind of block my adenosine receptors. That's not how we normally drink a cup of morning coffee or morning tea. Meanwhile, people get very nervous about anything that has weird names or long abbreviations. Oh, that's drugs, that's evil. So, what else do we have here that might be worth mentioning? Well, a lot of these drugs were developed, of course, not because we wanted to make people smarter, but simply because of side effect of normal pharmaceutical research into treating Alzheimer's. And then, of course, some people immediately found out that it seemed to work more or less well on healthy people. A lot of these cases, however, there is just a handful of papers, so the amount of good scientific evidence on how well they work for normal people is actually surprisingly weak, despite all the interest. So there's this annoying situation that you can certainly do a lot of nice, profitable research about it in order to treat somebody, but figuring out what it does on healthy people, that's kind of a side effect. Even if an awful lot of healthy people are then going to take your drug and enjoy this so-called side effect. So one guy in Barbara Sakan's group did a rather interesting study. So one of the fun findings he found was also that it affects creativity. Yeah.
On the last slide, you had sildenafil.
Yep. Viagra.
Just that.
Yeah. So it's weird. It's weird. Where did I have it? Oh yes, yeah. I even added actually an exclamation mark here. It actually seems to be a memory enhancer. It's really weird. So probably it's because it does something with nitrogen oxide in the brain. Nitrogen oxide is a really weird signaling molecule. And it's of course doing other interesting things in the rest of the body, hence the big market for Viagra and related compounds. But in the brain it also involved actually memory. And it seems to have a bit of a memory enhancing effect, which is kind of interesting. It also seems to help performance in mountaineering. Yeah, exactly. So at least in mountaineering it makes sense. So, yeah, but I'm not certain what one is to make of that. Except that it gives you a very fun excuse for buying Viagra. Oh yes, I'm just going to use this for studying. And that's of course one of the interesting problems with a lot of these drugs. If you want to figure out how many people are using them, especially typically people are concerned, oh, students must be using them. So you send out surveys and go out on campus and ask people. And a lot of people will of course not really want to say, yeah, I'm taking amphetamine because it's a party drug. So they like to say, oh yes, I'm taking it because it's an enhancer. So a lot of these studies should be taken with ridiculous amounts, grains of salt. We shouldn't trust it. And of course, when you get over to the more exotic uses like Viagra, well, who knows? There haven't been any proper studies of that at all, as far as I know. We're hopefully going to get slightly better studies in the near future, but we'll see. In any case, Mohammed did a fun study. He found that creativity in low-performing subjects went up when we got modafinil, but it went down in high creative subjects. That's kind of awesome. He also found that people's happiness with doing the fairly boring psychological tasks also went up when they got modafinil. So one reason why it might be a performance enhancer might not at all be that it actually makes you smarter. It might just be that you enjoy doing slightly boring stuff more. So you do it better. And to me, I've been arguing with him about this, that's actually pretty good. There is a lot of slightly boring stuff I want to be done. And if that happens because I happen to enjoy it due to a pill, well, so much better. He felt that that was not a good argument. He also felt that creativity is something so important that we should not take any risk of damaging. While I realized that quite a lot of stuff I do, I don't want to be creative. I want to be very non-creative and just finish the darn paper. So again, we have this problem. We need to understand the tasks we're doing and what we want to get out of it. And that might be quite individual. So it's not like we're going to be able to take that little limitless pill and get everything just done very quickly and rapidly with a sheer stroke of genius. It's most likely that we need to think, now I'm going to need to learn stuff. Okay, I need to go find something that is a learning enhancer. And then I need to get a lot of sleep because I want to consolidate those memories. That's one of the big problems with all-nighters. Yeah, you're up all night and you may be trying to cram, but you don't get enough sleep, so none of that beautiful information you manage to cram into your hippocampus gets moved over to the cortex, so you just forget it next morning. So it's really important to sleep well. Okay. Well, I'm late with the talk and so on, so let's jump on and see what else. Oh yes, we have interest in doping classical music, people using beta blockers to get over stage fright. There are even a few papers looking at whether this affects the quality of the music. And the views are divided. Apparently technical performance in piano goes up, but it wasn't very emotional, and the vibrato was slightly different in singers. Again, I think this is a matter of taste, but it's kind of interesting to see these cases. And then, of course, we have, well, I don't have time for that. In the future, I think what the really big thing is going to be when you actually try to get these drugs to the right part of the brain. Because essentially what we're doing right now is soak the brain in a small molecule. It's going to fit to a lot of receptors. And, well, it's going to affect function in the right way in some places, and in other places it's just going to mess things up. That's, of course, why most drugs have a lot of side effects. So one of the most exciting parts of current pharmaceutical development is trying to encapsulate drugs in really, really clever ways. So this is a so-called walled protein. So they're found in essentially all cells. And we don't really know what we're supposed to do, but we seem to be able to encapsulate stuff really well. Now, clever bioengineers, of course, realize that, if we could get our drug into those proteins and get them to open in the right spot, we could do a lot of really awesome stuff. And of course, you can try to use something completely artificial too, but nature has already provided this. Another cool way of encapsulating stuff is DNA origami, which is also really, really amazing. You just make use of the fact that if you have a DNA sequence and you make the right spots that are complementary, it tends to fold together to fit them. So then you just figure out how to turn, essentially create a sequence that will fold together into smileys. Or why not boxes? Of course, DNA is rather floppy and the body is pretty good at breaking it down. So this is also kind of limited, but it actually shows where we are right now in terms of kind of biotech, nanotechnology. I wouldn't be very surprised if we're going to, within a decade or two, figure out how to make actually drugs that are really smart in the sense that they get to the right spot in the brain and only there they open up. And we might even be able to tune that, for example, by making them sensitive to the right electromagnetic fields. So we put a magnet on the right spot. This is partially how people are trying to use nanoparticles today to treat cancer. Essentially, you have a little metallic nanoparticle, the right kind of antigen, so they're going to stick to cancer cells. And once you have enough of these metallic nanoparticles, you start sending in a lot of microwaves. The particles get hot. That's not good for the neighbors, the cancer cells, and hopefully the cancer gets cured. Somebody during one of his talks about this asked, but wait a minute, what about those metal particles afterwards? Are they going to go away? And the answer is, of course, no, they accumulate in your lymph nodes. But as the lecturer said, well, it's better than having cancer. Another way you can mess with your brain in fun ways is, of course, indeed to wobble electromagnetic fields over it. So this is called transcranial magnetic stimulation. And essentially, you wobble a magnetic field, it induces currents. If you do this with the right frequency, cells in your cerebral cortex become easier to excite. Or they might become less easy to excite. You can actually dampen a part of your cortex. You only need to put the coils at the right spot. And this seems to be able to act as an enhancer for an awful lot of things. For example, you can use it as a memory enhancer by making part of your temporal lobe more plastic, more easy to stimulate by your experiences. One of the fun things is that this is even more improved if you actually reduce the activity in your frontal lobe. It seems to get in the way of encoding your memories. But when you want to retrieve your memories, now you should actually flip things around. You actually want your frontal lobe a bit stimulated and inhibit your temporal lobe. So it's not always all part of our brain are good for each other. Sometimes it seems like they're just getting into each other's way. So one of the interesting problems with this kind of setup is, of course, that you need to put it over the right spot of your brain. And again, our brains are fairly individual. Actually finding the right part of the cortex, you can, of course, open your anatomy atlas and make a good guess, but you don't know for certain that that's the area you get. But it's quite interesting, and you can use it on a lot of different topics. Over here in Oxford, we have got Roy Cohen-Kadosh, who's been using a similar method, where you just use a direct current. Essentially, you take a current from a small battery and run it through the scalp. And amazingly enough, this works. And he's been using that to influence people's ability to learn mappings of mathematical symbols. So he's been using ancient Syrian letters and been kind of teaching people on artificial mathematics using them and demonstrating that this kind of stimulation makes it easier to learn how to handle them and actually get a sense of their size and mathematical properties. It's quite awesome. It's also kind of mildly disturbing because you realize, wait a minute, a battery, electrodes on your head, that's not terribly hard to do. I've been constantly talking about people are going to make thinking caps like this, and I met one guy actually last weekend who indeed had one. So he was sitting across me at the table, and he was kind of explaining the different settings. He was controlling his thinking cap also using a little iPod mini. It was looking awesomely cool in a kind of very weird, mildly mad science way. One problem here is, of course, the placebo effect is going to be total, of course. You built a device, you're sending stuff to your brain, and you know exactly what you're supposed to be feeling because you programmed it in on your iPad. So it's going to be tricky, of course, for him to convince me that he's actually doing it, but you can probably run double-blind tests. And there's some interesting applications. The American military have been trying it in virtual reality to make people better able to find hidden bombs. So essentially, they increased the ability to quickly learn these kind of visual patterns that shows that the signs of, in their training virtual reality, this is a bomb. I'm slightly doubtful this is going to help in the real reality, but at least as an experiment, it's pretty awesome. All right. I'm running late here, so I'm going to mention, of course, just briefly genetic engineering. A lot of you have probably seen the Doogie mouse. So it got extra NMDA receptors. And it's essentially much more sensitive to learning. It's also more sensitive to inflammatory pain, which makes it a wonderful kind of philosophical thought experiment. Would you be willing to get better memory at the price of having a bit more aches in your life? And at least I would say aspirin. But it's an interesting question what kind of trade-offs we want to have actually in our enhancements. And today we have a fairly long list of ways of enhancing memory in mice. And these memory systems exist, of course, in humans. So although it might be tricky to enhance humans, and I don't think it's worth that much to try to genetically engineer your kids, it might be useful to actually try to figure out how to affect these particular molecules and receptors in our brain, perhaps using drugs, perhaps using other methods. And then, of course, you can give new senses. So this is one a really awesome experiment where we actually made, I think this is capuchin monkeys, and who are, they only have 2 color receptors. So by human standards, they're colorblind. And using a bit of gene therapy, we added an extra color receptor to the retina of their eyes. and they became able to actually use this information. The really awesome thing about this is that they actually got a new set of colors that didn't exist in the perceptual world before, and they could make use of it. So I really wanted to have something like this. I want to be able to see in ultraviolet. I want to see the patterns of those spring flowers out there that only the bees can see. Of course, you might argue that this is not a real cognitive enhancement, but I think it's close enough. The retina should be counted as part of the brain. And then, of course, we have a lot of things about trying to plug in the brains to computers. I'm running short of time, but the classic method is, of course, try to set electrodes and use EEG. And this can be used, for example, for trying to send messages, which is really useful if you have nothing else to do. So if you're really paralyzed, this is a good method. So you select a letter, let's say S, and then it flashes rows randomly. And of course, every time you see your letter flash up, your brain reacts to that, and there is a particular waveform that can be detected. After a while, it starts flashing columns, and it takes you probably just about a minute to write that S. So it's really, really slow. You need to be pretty desperate or really determined in order to use it. But it's still kind of a real improvement, of course, if you can't move. But it's the problem that we're measuring from a lot of nerve cells here in the brain. We're getting an average of millions of nerves. It's a bit like listening to traffic noise to figure out what's happening in a city. It gives you a bit of a hint, but not much detail. Still, you can make music using it. I was at this concert. The musicians were controlling the electronic instruments using these EEG systems. Let's just say that it was very modernistic. And of course, you can use it for other fun art. This is Stellark, an artist who is very keen on connecting all sorts of cool technology to his own body. So his third arm, for example, is controlled by electrodes, not so much on his head, but on other parts of his body. And he can do some pretty cool things like write with 3 hands simultaneously. But of course, only 6-letter words, because you're only doing 2 letters per hand and so on. So he's got some limitations. But in practice, we probably want to get these signals with more resolution. Of course, some people have been trying to use this for lie detection. So these evoked potentials, as we call it, for example, when you recognize something. Now, if there had been a murder and the murderer is supposed to know the murder weapon, and you show a witness a number of weapons, and one of them is the murder weapon, well, if that witness is the murderer, there should be a particular response that differs from all the other weapons. And of course, if he doesn't know anything, there shouldn't be any response. So you can at least in theory see how this could be used to kind of make a guess at who might actually know something. At this point, of course, most people will immediately start seeing problems with this. That hasn't stopped people from commercializing this and selling this to law enforcement who doesn't know very much about neuroscience, statistics, or the philosophy of evidence. And there have even been a few cases of convictions, which is downright frightening from a neuroethical standpoint. But it also shows how much we're willing to believe it, because it's the brain. The brain doesn't lie. Ha! Another cool application about actually measuring stuff straight from the surface is done by the American military. So their typical problem is that they have a sentry looking out of a piece of desert, and somewhere out there might be a nasty person crawling up to him with a gun. So ideally, you want to be able to detect if nasty people are crawling up on you. And this is very easy for humans to do the first 5 minutes. After that, you get very bored, you start falling asleep, you don't pay attention, or you start doing the crossword. At which point, of course, the nasty man with a gun has a pretty good shot at you. So the solution is, of course, let's add a camera and a computer program to look for nasty people with guns. Unfortunately, it turns out that nasty people with guns are very similar to rocks and cactuses and a lot of other things, at least in the mind of a computer. So the computer typically finds a lot of false positives everywhere in a big picture. It has a great visual acuity. It can see really far, but it's going to notice a lot of cactuses. The solution is, of course, humans are really good at detecting nasty people. So what you do is you have a camera and computer, and the computer figures out a lot of little snapshots or pieces of a landscape that look interesting. And of course, you could just be showing them at a slow rate to somebody sitting there. But that's not very effective. A much better method is actually to have somebody sit there, and then you flicker through them about 10 per second. Really fast. You can't really pay much attention. But your visual system tends to react when you see a person. So what happens is you see a rock, cactus, a nasty person, more rock, and you have a brief reaction. Your visual system, subconsciously or pre-consciously, detects that. You detect it using the EEG electrode, and you can go back. Oh, look, there is a nasty guy behind that rock. Throw a missile at him. Well, this is, after all, the American military we're talking about. But it's also kind of beautiful example where you can kind of get the strength of a computer working together with a human really, really well. I'm just started to be concerned here that time-wise I'm probably kind of getting mildly over time here. And I can, of course, as you might guess, go on for hours. So maybe I should open up more questions like, what would you like to know?